So in acid-base balance, just this water balance, functions of water and all are not that important. It's a general topic. So distribution of water may be asked sometimes as a 3 marks question. Like how much is the intracellular fluid? The body weight is composed of 40% of intracellular fluid. So total volume is coming to 28 liters intracellular fluid. Like that, this table and 99.9% even this is not that important. Water turnover, water intake. This is actually mostly like related to physiology. See, whatever water we are taking, so in the nephrons, the water gets filtered, no? So that actually blood is getting filtered to form urine, isn't it? So the loss of water in the nephrons is prevented by these hormones like vasopressin, which is coming from posterior pituitary, antidiuretic hormone. This is also one of the hormones coming from the pituitary itself. So posterior pituitary. So these hormones basically, vasopressin is also known as antidiuretic hormone. It prevents the loss of water from the renal tubules, promotes reabsorption of water from nephron. Okay, so that water balance is maintained. So suppose if ADH or vasopressin is not released from posterior pituitary, there will be heavy loss of water in the urine. The water will be like tasteless urine, it is called as. That condition is diabetes insipidus. Okay, so that is deficiency of ADH, antidiuretic hormone. So we know not only we lose water in the form of urine, we see in the summer we have also loss of water in the form of sweat, isn't it? So skin,
Yes, ma'am.
Lungs in the form of water vapor, fecal matter also there is loss of water. So there is, these are the different forms, like we are taking water, drinking water. In the food also we take water, metabolic water is 300 ml. So water is lost in the urine, skin, lungs and fecal matter. So intake is around 2.5 liters, that is 2500 ml. Output is also same. Okay.
Yes, ma'am.
So electrolyte balance. These definitions are sometimes important, beta. What is osmolarity? What is osmolality? So these are definitions which you just need to by heart. Number of moles per liter of solution is osmolarity. Number of moles per kg of solvent is osmolality. Okay. Then this is also not required, beta. Don't trouble yourself unnecessarily. Have you gone through nucleotide chapter in the question bank?
Yes, ma'am. I went through, ma'am.
Did you find any question which we didn't discuss?
No, ma'am. All were there, ma'am. All of the questions.
Okay, nice. That's nice. Okay, but all these are not important, so unnecessarily don't trouble yourself.
Yes, ma'am.
These are important. Dehydration. Sometimes this question may be asked better. Dehydration, loss of water from the body is nothing but dehydration. It can be like in summer, the people who work in hot sun, like the laborers, construction site. So you see, if they are exposed to hot sun, most of the people, they will be dying nowadays in summer due to dehydration, isn't it? We call it as sunstroke, isn't it? So that is heavy loss of water is dehydration. It can be due to sunstroke or it can be due to loose motions and vomitings. Okay. So if there is an infection also, you will see there is heavy loss of water either in the form of vomiting or in the form of loose motion. So in all such cases, to prevent death and also to prevent water imbalance, immediately we have to give, first of all, water intake. Along with that, it's always wise to give ORS, oral rehydration solute. Okay, we can prepare at home also. A pinch of salt and 2 tablespoons of
sugar.
Sugar in 1 glass of water is also sufficient. So it will replace the electrolytes which are lost, and glucose will give the energy which is required. Okay, so dehydration has to be treated immediately. Otherwise, patient may go into like coma and die also. Okay, because water imbalance is very dangerous. So causes are like it may be due to like loose motion, diarrhea, vomiting, excessive sweating. It may be due to burns also. Suppose if adrenocortical deficiency, in the sense we know adrenal cortex is releasing which hormones? Aldosterone. Aldosterone is very important for the reabsorption of water from renal tubules. Same like ADH. Just a minute, beta. My HOD ma'am is calling.
Yes, yes, ma'am. Yes, ma'am.
Sorry for the delay.
No problem.
So dehydration, like, see, I told you the various causes. So what happens in dehydration? So there are 3 degrees, like mild is there, moderate and severe. So you will see the volume of extracellular fluid is decreased. Okay, that is extracellular fluid is nothing but blood volume, beta, plasma volume. Okay, so
Yes, ma'am.
whatever water is lost in the form of urine, in the form of loose motions or vomitings, that is all drawn from the plasma of the blood. Hence, you will see the concentration, that means the osmotic pressure in the blood will increase. Okay, so the water is drawn from intracellular fluid that results in shrunken cells. So ADH secretion is increased. This causes increased water retention. Okay. So this is one of the protective mechanisms. So plasma protein and blood urea concentrations are also increased due to heavy loss of water. So water depletion is often accompanied by loss of electrolytes. That's the reason we need to replace electrolytes as well. Sodium, potassium, etc. The clinical symptoms are low, like pulse rate will increase, BP will be low, eyeballs will be shrunken. So skin turgor also becomes very like less. Person feels weak, confusion and coma. Okay. So treatment, intake of plenty of water better. Then osmotic imbalance and dehydration in cholera. All these are not required, but more or less it is the same thing. We have to just give ORS acid, right? Oral rehydration therapy. ORS is oral rehydration salts. Overhydration in the sense, see, drinking water is good, but there is a limit for it. We should not drink beyond 5 to 7 liters per day. Thinking that it is good, and we are just loading our body with pouring our body with excess water, then you will see our body will be overhydrated. That's what is called as water intoxication, retention of water in the body. Okay. So it may be due
Yes.
to excessive intake of large volumes of salt-free fluids. It may be due to renal failure, overproduction of ADH, etc. Then water tank model and all is not required. Now, the real story of this chapter actually starts from here, acid-base balance. So the normal pH in the blood is, you should remember this, 7.35 to 7.45. Okay.
Yes, ma'am.
So this is the normal pH. So in our body, if you just see various metabolisms, continuously acids are produced, isn't it? Like suppose if you start with carbohydrate metabolism, we have the end product of glycolysis is pyruvic acid, pyruvate. Okay. Then we have aerobic and anaerobic type. So lactic acid
Yes,
is an acid,
lactic.
pyruvic acid is an acid. Then we have different types like ketone bodies. They are also acids. Okay. Acetoacetic acid, beta hydroxybutyric acid. Okay. Then different types of acids we have. So almost all metabolisms in our body, the end products are acids. So obviously, you will see acid production is more in the body, that you should remember. So in order
Yes,
to
ma'am.
compensate that, our body will produce, it will have alkali reserve. So there are buffers. In fact, whenever there is acidity more, buffer will neutralize it by adding more of alkali. Whenever alkalinity is more, buffer will work in such a way like acid will be like added to that particular solution. So vegetarian diet has alkalizing effect. Okay, we know that. So maintenance of blood pH. See, I'm telling you always our pH is maintained 7.35 to 7.4.
7.45. Yes,
Isn't it?
ma'am.
So that means what? There are certain mechanisms which are working strongly to maintain this pH. We have blood buffers. This can be an essay beta. Respiratory
Yes, ma'am.
mechanism, renal mechanism. See, blood buffers. That means in the blood we have buffer system which will actually see that pH is maintained always constant. Now, suppose you see here, buffer, what is the definition? We should know definition of buffer. It's defined as solution of weak acid and the salt with a strong base. Okay. So buffer is resisting the change in pH by addition of acid or alkali, and the buffering capacity is dependent on absolute concentration of salt and acid. That means buffers are nothing but they are maintaining the pH. They will not change, allow the pH to change. That is the function of buffer. So you should remember, like it's a solution of weak acid and it's salt with strong base. So the blood contains three buffer systems: bicarbonate buffer, phosphate buffer, and protein buffer. Three buffers. Okay. So bicarbonate buffer. So in the blood, these are the three chief mechanisms beta which will keep the pH always constant. Let us talk about bicarbonate buffer first. See, we have a universal formula which we have been studying so many times, like CO2 plus H2O, isn't it? It combines to form H2CO3, carbonic acid. So this carbonic acid further splits into H plus and HCO3 minus, hydrogen ion and bicarbonate ion. Now, by the law of mass action, we are just doing simple mass here, beta. We are just writing this is the law, like law of mass action Ka is equal to H plus HCO3 minus. This is coming under the numerator. This you are taking it down, H2CO3 denominator. So K is nothing but dissociation constant. Now, in the next step, a simple mass, you are just doing cross reaction, like cross equation like this. So hydrogen is coming this side. So this H2CO3 is going up and HCO3 is coming down and Ka is coming towards right hand side. So there is a like a normal thing what we know, like pH is nothing but log 1 by pH. So instead of writing log 1 by H, instead of writing this, we will what we write now is we are substituting log everywhere. See, H is there, no? There you will write instead of H, see, log 1 by H, log 1 by Ka plus log. Everywhere log is just written along with the formula which is already written. So log 1 by Ka is nothing but pKa. So instead of writing log 1 by Ka, now you can write pKa. Log 1 by H plus is nothing but pH, no? See, log 1 by
Yes.
H is nothing but pH. So instead of writing log 1 by H plus, you will write pH. So pH is equal to pKa, simple mass better, log HCO3 minus H2CO3. So above equation is valid for any buffer pair. The general equation is referred to as Henderson-Hasselbalch equation. Okay.
Yes, ma'am.
So HCO3 is indicating base. H2CO3, this is carbonic acid, which is representing acid. So
Acid.
pH is nothing but it's a ratio log of base to acid. Now you will be given certain values which will be substituted with them. So now you have values like C, blood pH and ratio of HCO3 to H2CO3. Bicarbonate HCO3 concentration is around 24. That means this one. In the numerator,
ma'am.
you should write 24. Carbonic acid, how much is that? 40 ml.
40.
Now see, thus H2CO3, it comes to 1.2. So that means 24 by 1.2, Shubhangi. The numerator, you write 24. In the denominator, you will write 1.2.
1.2.
So if you just simplify that, how much it will be? 12 ones are 12 twos are and that means point goes up, no, to 20. So base is 20 times more when you compare with acid. Why do you have so much of base in our blood? Alkali reserve it is called, because every metabolism end product is acid only. Lactic acid, phytic acid, acetoacetic acid, beta hydroxybutyric acid, everything is acid only. So in order to neutralize so many acids formed in the body, our body has alkali reserve. Okay, beta? That's what you have written. 24 is acid, no? Sorry, base. And
Base,
acid is
ma'am.
2.2. When you just simplify it, it comes to 20. So in the numerator, you have 20. By, if nothing is written, that is nothing but 1, 20 by 1. So 20 times more when you compare. No, certain values are given, I said, right? So we're just substituting in this formula. Shubhangi, this is the formula. pH is equal to pKa plus log, right? So pH, we know the normal pH is 7.4. Now when you simplify this, you will get 7.4. pKa is 6.1 and you're substituting this. Log 20, when you see that log book, you will get 1.3. So 6.1 plus 1.3 is nothing but 7.4. Okay. So this is the pH, which is derived. So now you're seeing it's evident, like the ratio of bicarbonate to carbonic acid. Bicarbonate
24.
is carbonic acid is acid. 20 times more we reserve. Okay. So this is extracellular buffer system, whatever we have studied till now. Predominant buffer which you see in extracellular fluid. There is one more buffer system in the blood. These are all blood buffers, right? Phosphate buffer. So phosphate buffer is the powerful buffer what we see inside the cells. This is powerful intracellular buffer. Okay. So what is the formula of phosphate buffer system? Sodium dihydrogen phosphate and disodium hydrogen phosphate. Okay. Then protein buffer. So these are nothing but plasma proteins, beta albumin, globulin, prothrombin, fibrinogen, hemoglobin. All these, no, they are also acting as buffers which will prevent the change in pH in the blood. So these are blood buffers. So once blood buffers are over, what do we have? Two more buffer systems we have to regulate pH. Second is respiratory. And the last one is renal mechanism. No, in the respiratory mechanism, generally we are inhaling oxygen and exhaling carbon dioxide, right? So when we do exhalation of carbon dioxide, basically excessive acid is washed out. That is also one of the protective mechanism. So suppose whenever there is retention of carbon dioxide in the blood, in the medulla oblongata, we have respiratory centers, what we have studied in physiology. So those respiratory centers will be triggered so that there will be hyperventilation. Hyperventilation in the sense the rate and depth of respiration will increase. Okay. So whenever rate and depth of inspiration and expiration increases, carbon dioxide is washed out. It is swept out. Hence, the pH is coming back to normal. So this mechanism will be explained in this paragraph. Just go through once, you will definitely understand. Okay.
Yes, ma'am.
Next, the third and very important mechanism. See, this is general thing, but about we see inside the RBC, that is nothing but happening in lungs. So suppose if more carbon dioxide is there in the blood, it is transported inside the RBC. This is universal formula. CO2 plus H2O in the presence of carbonic anhydrase. This is an enzyme. It is converted to H2CO3. Isn't it? H2CO3 is now broken down to H plus SCO3 minus. SCO3 minus is transported to plasma. H, it is combining with hemoglobin to form H hemoglobin. Okay. Then chloride bicarbonate shift. This is more important in physiology, beta. Okay. So chloride, that means for one bicarbonate which is being stored in the plasma as alkali reserve, chloride is transported to erythrocyte. You call it as chloride bicarbonate shift. This is what is happening in the lungs. Same thing will be actually elaborated, chloride shift. Okay. Next, we have renal mechanism. Kidneys, how are they working? Kidneys play a major role in the regulation of blood pH, beta.
Blood
It
pH.
has
Yes.
4 different mechanisms how it works. Very simple and easy, and almost CO2 H2O is universal thing goes on. Now see, this is the tubular cell. This is the lumen of nephron. Okay, from the lumen of nephron, what is happening? See, you have to first talk about this tubular cell. Again, same universal formula, Shubhangi, CO2 plus H2O, carbonic anhydrase, H2CO3. It is splitting, H plus SCO3 minus. SCO3 is always safe side. Where is it going to? Blood. Alkali reserve, no, bicarbonate. It is stored.
Yes, ma'am.
So along with that, you are finding this hydrogen ion. All acids are excreted in urine. That's why urine is acidic, isn't it? Hydrogen ions are moving to the lumen of nephron, and it is just combining with some base to form salt, which is excreted in urine. Okay, so this is first mechanism. What is that? Excretion of hydrogen ions. Second is reabsorption of bicarbonate. Actually, reabsorption of bicarbonate is also shown here, in fact, isn't it? This bicarbonate of the tubular cell is transported to the blood and stored. Similarly, but again, it is written the same thing, in fact. A regulation of blood, reabsorption of bicarbonate. See here, this is tubular cell. Same thing, but CO2, H2O, H2O, hydrogen ion is going into the tubular lumen. This bicarbonate is reabsorbed in the blood. So hydrogen ion, now here, there B was written, no, like acid, base, salt and all. Instead of B, what is written here? So hydrogen is combining with like bicarbonate to form H2CO3. This is acid, carbonic acid. No? So in the presence of carbonic anhydrase, again this is transported to tubular cell. घुमा फिरा के फिर वही है बेटा, सेम ही, ठीक है?
Yes, ma'am.
Then what is the third mechanism? We have excretion of titratable acid. Now let us see that third mechanism. ये भी simple है बेटा, same thing. Tubular cell, lumen and blood. CO2, H2, bicarbonate is observed, and now hydrogen ion, which is now moving to lumen of the nephron, it is now combining with sodium hydrogen phosphate, NaHPO4. This H plus this H, what happens? H2, isn't it? Same formula hai dekho, NaH2PO4 now it has become. So it is a salt which is excreted. Initially in the lumen, pH of urine was 7.4, same like blood. Now because now acids are being added to the lumen, fluid of the lumen, you are finding it is now urine is becoming acidic. It is 4.5. Okay, everywhere you can see the acidity. The last mechanism is, see, like excretion of ammonium ions. That is the last mechanism, but more or less same thing. CO2, H2O, ये सब same है बेटा. यहाँ देखो आप, this hydrogen is now combining with this ammonium. We have studied transamination, deamination, right?
Yes, ma'am.
So deamination से जो ammonia बाहर आ गया is coming into the lumen, and it is now combining with hydrogen ion, which is present in the lumen of nephron. It forms the ammonium ion, okay, which is excreted. So this is nothing but excretion of ammonium ion.
Ammonium ions.
These are the 4 different mechanisms which are operated in the nephrons of kidney for the regulation of pH. Okay, beta? Yes, ho gaya.
Yes, ma'am.
Then disorders of acid-base balance, we have acidosis and alkalosis. It can be respiratory or metabolic. So for which you have this thing. So if you understand this, the theory part you can easily understand. Metabolic acidosis, that means we have various metabolic disorders where acids are excessively synthesized. जैसा diabetes mellitus है बेटा, ketone bodies ज़्यादा produce होते ना, acetone, acetoacetate and beta hydroxybutyrate. So you call that as metabolic acidosis. Renal failure, again acids are not excreted. Lactic acidosis you will see in the person who works more muscular. In case of diarrhea, all these are the examples of metabolic acidosis. Okay, then similarly we have respiratory also. Respiratory, it may be due to asthma, pneumonia, cardiac arrest, and so on. Metabolic, in acidosis, hydrogen ion levels are increased beta. Reason may be either metabolic disorders or lungs are not properly functioning. Metabolic alkalosis or respiratory alkalosis, in the sense in the blood, bicarbonate ions are increased. It may be due to underlying metabolic disorders or it may be due to failure of respiratory system. Okay, Shubhangi, and these are the examples.
Yes, ma'am.
This is also important, beta, anion gap. Unmeasured anions and cations, whatever we have, no? See, unmeasured anions in the plasma, this forms the anion gap. What does it mean? See, anions are negatively charged ions, right? See, he has given one example, like in the plasma, we have sodium, potassium ions, which are equal to chloride plus bicarbonate, plus certain anions which are not measured, A minus. See, 136 plus 4 is equal to 100 plus 25. So, but there are certain anions which are not measured and which is coming to 15 milli equivalents. Okay.
Hmm.
So
Yes,
that
ma'am.
is nothing but creating a gap in the plasma, which is called anion gap. All these 4 disorders, try to read in detail, beta, because anything can be asked either for 5 marks or 3 marks. Okay, metabolic
Yes, ma'am.
acidosis, respiratory acid. घुमा फिर आके फिर बार बार वही रिपीट करा बेटा, मैं आपको कॉन्सेप्ट अच्छे से समझा. Okay, so that finishes this chapter. Okay,
Yes, ma'am.
that's it. हो गया. So we will stop here.
हाँ, ma'am.